Okay, so we stopped there last time. Conditional expressions. Remember, we said that we have three types of structures. We have the sequential structure, the selection structure, and the iterative structure. So here we are discussing the selection structure. We already discussed this. We discussed the ternary operator. We said this is the only operator in C that takes This is the only operator in C that takes three operands, this, and this. So it evaluates the first set of operands. If the result is true, then the effective value of the entire expression will be this. If the result is false, the value of the entire expression will be this after the semicolon. Okay, so we used it in different instances. We already did this last time. So we'll start from here today. The switch statement. In our previous examples, we have done the case of if and else, a cascaded if statement. So we have done if and else, and then under the else, we have another if. We have done this several times. But we can make use of something else called the switch. Observe one thing, that in every if you are evaluating, you are making an evaluation. See, you are making an evaluation. And this evaluation is making use of CPU too much. We can make use of the switch statement that does all these evaluations only one time. And after doing it one time, it just picks the appropriate case easily. The switch statement. The switch statement is an alternative to the if and else statement. So here is the situation. Here we already got the value of grade. And so we are checking if grade is equal to 4, if grade is equal to 3, if grade is equal to 2, if grade is equal to 1, and if grade is equal to 0. So we are checking the value of grade against different constants. But with the switch statement, we know the value of grade. And so we are checking the value of grade as cases. If the value of grade is 4, if the value of grade is 3, this is how we run the switch statement. So this is the general structure. Switch, an expression, and then we open parentheses for the body of the switch. Inside of the body, we write different cases. Case, observe that case is small letters, space, the value, the fixed value that you're checking, and then full colon. You write whatever you want to happen in that case, and then you put a break keyword. Now, this break means that whenever you come to this break, jump out of the entire parentheses, jump out of these curly braces. That is meaning of break. So if it gets to this break statement, execution leaves the body of this switch and comes outside of the switch. A switch statement may be easier to read than a cascaded if. The switch statements are often faster than if statements. Switch statements are often faster than if statements. This is what I was explaining to you. If statement makes use of a lot of CPU evaluation, but switch statement is faster than the if statement. So this is the general structure like I explained. The switch keyword, an expression in parentheses that you are trying to evaluate, and then you open the curly brace, which you close later. Next, you write the different cases that you want to check, and in front of them, after a space, you put the constant expression. The constant expression is not a variable, not a value that can change. It is something that is fixed. This is important. This is really important. It must be a value that is fixed, a constant. So we have the statements we want to execute, followed by break. If we want to break, if you don't want to break, you may not remove break, you may not put break. If I remove break from here, if I remove break from here, what would happen is, let's assume our grade is 4. So it comes here, checks case 4, finds case 4 to be correct, prints excellent. Because there is no break, it moves to case 3 immediately and prints good also. Now, after case 3, there's still break. So it breaks from here and then it jumps out. So you can put break and you may not put break. It depends on what you want. But in most cases, we need break. So we use break. And finally, we have a default case. This is important. We have a default case. So in case the compiler cannot find any case to be correct, any case to match your expression, it must have a final thing it can do, and that is the default. So the default means if all the cases are wrong, just do what is in default. The word switch must be followed by an integer expression, the controlling expression in the parentheses. So let's clear everything on this slide side. Now, this is the switch keyword followed by an expression. This expression must evaluate to an integer, not a floating point, not a char, not a string. Okay, we can use a char, but later you will understand why we can use a char. But we want this expression to match an integer. Oh, the answer is even here, so you'll understand from here. It must be followed by an integer expression. And also, this expression is called the controlling expression. The controlling expression. It controls the switch statement. Characters are treated as integers in C and so can be tested in switch statement. So this is the reason why I said you can use char in switch statement. Why? Because A actually in switch statement is 65. A is integer 65 in ASCII. A is, I think, if I remember, 97 in ASCII. So if you try to switch using A, even though you are writing A, the compiler is saying 65, and 65 is an integer, so it would work. Floating point and strings must not be used to control the expression. Each case begins with a label of the form case, a constant expression, and then the full colon, just like what you have here. The case, the constant expression, full colon, and any statement you want after the full colon. A constant expression is much like an ordinary expression, except that it can't contain variables or function calls. It's like a normal expression, but it cannot contain a variable. So something like this cannot be used in that place. It's not a constant expression because n is expected to be a variable. Now, remember that we can have constants like macros. Yes, you can use macro here, but this is macro in case you have forgotten. This is what we call macro. This is macro. So m is a macro. You can switch using m because it's a constant. It cannot change. But you cannot switch using d because d is a variable. It can change. This is just the idea. So 5 is a constant expression. 5 plus 10 is a constant expression because the answer is fixed. The value of 5 plus 10 is fixed forever. The constant expression in a case label must evaluate to an integer. The constant expression also must evaluate to an integer. Again, chars are acceptable. I explained why already. Okay, let's have 10 minutes break. We'll come back from here. 10 minutes break and we'll be back. All right, so let's continue. After each case label comes any number of statements. So we need some statement to express, to evaluate. No braces are required around the statements. The last statement in each group is normally break. And if you remember what I told you earlier, it's not compulsorily break. Without break, it would work. I mean, it would do what it normally would do. So if what it would do without break is what you want, then it's fine. It is not compulsory for you to have break in every situation. Okay, so let's try an example. Um, let's try an example. Where's my dev C++? Oh, right. So what and what can we do? Okay, let's do something similar to the example we have in class. So let's say int score. So int f. So we get an integer and we check. So we can then have our switch. What could our score be? Let's say we have fixed value scores. Case 100. So when it is 100, I can print. Okay, so let's just move this to the front so it can be easy to identify. Oh, I wrote print instead of printf. Now observe that I did not put break. Okay, let's put new line. Let's put new line. It would be nice to put new line. Okay. Oh, okay. I think this is no. Okay, here we are. So what are we doing? We have our switch statement. Let's indent this a little bit. Okay. So we have our switch statement that is here, but the expression for evaluation is score. And we said the expression for evaluation must be an integer or anything that evaluates to an integer. So we can make use of score because score was defined as an integer and we received an integer using scanf. Now we check the case. If this case of score was 100, that means if the person's value inside score is 100, then it prints this, and next it breaks out of this case. As it breaks out of the case, it breaks completely out of the switch statement. But if the person scored 90, so it checks the case of the value of score. When it is 90, it brings us to this part. So it prints great, moves to the next line, but there's no break. So it prints good, moves to the next line, and then it breaks. If the person actually scored 80, it would print just good, and then it would break. If the person scored 50, it will simply fail. It will print failed, and then it will break. Any other thing, it would be wrong score. Goodbye. So enter your score. Let's say we scored 80. It says good. So 80 is good. You can see. Let's close it and put a space after this enter your score. Okay. Now it's asking enter your score. If we use 90 to print great, good. So you see, without break, the code will not stop working. It would only do what it can do without break. So it displays great, good. So let's test with 100. It says excellent student. Let's test now with default. If you observe, we don't have the case for 85 or 95. So let's try with 95. It says, oh, we don't know 95. 95 is not defined as a case. So it's a wrong score. And this is where we need to use default. So it says wrong score value. Goodbye, which is for the default. Any question? Okay, to save lines, if you have several cases that amount to the same value, you can just connect them together and use them together. If the default case is missing and the controlling expression's value doesn't match any case, control passes to the next statement after the switch. So what this means is, if the default does not exist, if we don't have this part, what happens is just that if we set any value that isn't here, nothing will just happen. It will just pass control to return 0. So when we get here, it checks all the conditions. No case is meeting our value of, let's say, 95, and we don't have this part. So it just forgets about 95 and comes to the next line outside of the switch statement. The role of break. Okay, I think somehow I already explained this. Executing a break statement causes the program to break out of the switch statement. Execution continues at the next statement after the switch block. The switch statement is really a form of computed jump. So it helps us to jump to a specific part of the cases. When the controlling expression is evaluated, control jumps to the case label matching the value of the switch. He said when the controlling expression is evaluated, what is the controlling expression? Score. So it says when this controlling expression is evaluated, evaluation jumps to the case that matches this value. So if the value of score was 50, execution jumps from here to this place. And this is why the switch statement is faster than the if else statement. For if else, it has to evaluate the else if several times. But for the switch, it evaluates only once and jumps to the appropriate place in the code. So that is why we call it a computed jump. A case label is nothing more than just a marker indicating a position within the switch. So without break, some or some other jump statements at the end of each case or at the end of a case, control will just move to the next one. So here is an example. If we have case 4 is print excellent, we didn't put break. Case 3 is print good, something like this. What will happen? If we have the value as 3, it will start at case 3, it will print good. It looks for break, there's no break, it prints average. It prints poor, failing, it prints illegal grade at the same time because there is no break. So omitting break is sometimes done intentionally, just like we did in our last example. We did not put break deliberately, but at times it is just a mistake. So it's a good idea to write some comments in your code if you want it to not have break, so that later when you are debugging the code or when you are checking the code, you are not confused about why there is no break there. So the last statement never needs break. Why? Because there's nothing to fall into. Even if you don't put break here, there's no problem because there's no new line it would fall through to. But it's always a good idea to include one. All right. So we will move to the next thing now. Okay. We go to the next thing, loops. Further loops. We discussed this also already at the beginning. We said we have selection structure, we have sequential structure, and we have iterative structure. So this is iterative structure. In iteration statements, we try to do a single thing several times. 6 iteration statements are used to set up loops. Just a minute. It seems I cannot. It seems I cannot mark. Yes. Okay. 6 iteration statements are used to set up loops. A loop is a statement whose job is to repeatedly execute some other statement. So a loop statement is a statement that helps us to execute another set of statements several times. In C, every loop has a controlling expression, and the controlling expression is what determines when we will stop the loop, or even if we will start the loop. Each time the loop body is executed, the controlling expression is evaluated. So whenever we execute something in the loop, we check this controlling expression if it is still true or false. If the expression is true, that means it has a value that is not zero. Then we evaluate the body of the loop. C provides three iteration statements. We have the for loop, we have the while loop, and we have the do while loop. Okay, we'll discuss them all very soon. Now, the while statement is used for loops whose controlling expression is tested before the body is executed. So there are some times that you don't want to evaluate the body at all before testing a condition. If that condition is met, then you evaluate the body. But also there are times when you want to evaluate the body at least once before you test if the condition is met. You know, sometimes at the beginning, you know the condition is always going to be met. So you don't want to waste time testing again. And that way, you can make use of, and for that case, you can make use of do while. So you do it first before you check the evaluation. So the do statement is used if the expression is tested after the loop body is executed. It is tested after it is executed. Now, the for is convenient for loops that increment or decrement a counting variable. But these others don't need a counting variable. I mean, they can run without a counting variable, but for loops generally make use of a counting variable. A counting variable means a variable that is used to help us to count how many times we will enter the loop. That is the meaning of counting variable. Using a while statement is the easiest way to set up a loop. The while statement has this form. Observe again that it is a statement. It has this form while, the expression that we will test, and then the statement will evaluate if the test is true. Expression is the controlling expression, and then statement is the body of the loop. Statement is what we will do if the expression is found to be true. So here is an example. While I is less than n, add 2 to I. So what are we doing? We are checking the value of I that is less than n, and we are increasing the value of okay, multiply I by 2. So we are multiplying I by 2. Maybe I can show something like this to you. Let's remove this. So here now we can say enter n. Enter n. So we expect the user to provide some value for n, which we have set inside the variable. So we can say int I also. Let's make another int I. I is equal to, let's just say I is equal to 2. I starts at 2. So it's, we can even say I starts at 1. It just cannot start at 0 because we are multiplying. So we can say while I is less than n. Okay, let's change score to n. Okay, so while I is less than n, we can say I is equal to I times 2. But at the same time, we know that this expression is the same thing as I times equal to. I believe you know that. It's the same thing. So let's print the value of I every time. I think that will be good. Let's print the value of I every time. If we want to print the value of I every time, we put a printf here. So after we do the multiplication, we print the value of I. Now, we want these two to happen in the while loop. So what will happen? We have to put them in a block so that they are part of the statement for while. So we do this. So we put them in the while block. Let's execute and see what will happen. Okay, it's saying we should enter hen. How many times do you want to evaluate the multiplication? If we say 5 times, what will happen? It will check. Is 1 less than 5? Yes, it would multiply I by n, by 2. And then it will print the value of I. What is 1 times 2? It is 2. So it prints the value of I as 2. Then it goes back up to check, is 2 still less than n? If it is yes, it multiplies it by 2 again. All right, so let's continue. So it prints 2, 4, and 8. Okay, let's put new line character so that we can easily get what is going on. Okay, now let's change it to 10. So it says 2, 4, 8, 16. So I is 1 the first time. 1 times 2 gives us 2. So it shows 2. It goes back, it says, is 2 less than n? N is 10. Is 2 less than 10? Yes, 2 is less than 10. So it brings us back to the code and multiplies 2 by 2. So we have 4. It prints 4 for us, and then it goes back to check. Is 4 still less than 10? Yes. Since 4 is less than 10, it multiplies 4 by 2 and gets us 8. Prints the 8 for us and goes back to check. Is 8 less than 10? Yeah, 8 is still less than 10, so it comes to line 10 and multiply 8 times 2. That gives us 16. It prints 16 for us and goes back to check. Is 16 less than 10? The answer is no, so it stops and it jumps out of the while loop. It jumps out of the while loop. When a while statement is executed, the controlling expression is evaluated first. If its value is non-zero, non-zero means true, zero means false, the loop body is executed and the expression is tested again. This process, this cycle of test, test, execution happens several times until the value becomes 0. Until the value becomes 0. When the value becomes 0, then it stops. The process continues until the controlling expression evaluates eventually has the value of 0. Okay, here is just a trace. I think with the example I had for you, you should already understand this. A while statement that computes the smallest power of 2 that is greater than or equal to n. Okay, this is the example we just did. Although the loop body must be a single statement, that's merely a technicality. Why? because we can use a compound statement. What's the compound statement? Use of the braces, curly braces. So these curly braces help us to group these two lines as if it's just a statement for the while loop. Some programmers always use braces even when they are not strictly necessary. So in this case, we have just one line. Because we have one line, we don't need to put braces. I mean, we don't need to create a compound statement. But it's a good idea to always create a compound statement. Because later in life, if you have to add more lines to this code, you don't need to start finding where to put the curly braces. It's easier if you put it in the since the beginning. The following statement display a series of countdown messages. So here is what we have. I is equal to 10, while I is still greater than 0. Print the value of I. So it means now I is 10. Is 10 greater than 0? Yes. So you say t minus d and counting. T minus, what is the value? Minus 10. We reduce I as post reduction. And then we come back again. Now minus 8 is like a countdown time. We are starting from time 10. So we count to 8, we count to 9, and we count to 9, 8, 7, 6, 5, 4, down till we get to 1 because we cannot get to 0. It says while I is greater than 0. So what is the last message? You cannot count to 0. So it's the last message is t minus 1, 1. Observations about the while statement. The controlling expression is false when a while loop terminates. So the last time the while loop executes, when it terminates, the controlling expression must have given a answer that is false. The evaluation of the controlling expression must be false because we need it to be false before we can stop the loop. Here is it again. Let me show you the code. So we keep running and running and running. When did we stop? We stopped when I became 16. And so what is 16 less than 10? Remember, we gave n as 10. What is 16 less than 10? 16 is not less than 10, so it is false. Only when this expression becomes false is when we stop the while loop. As long as this expression is still true, like in the case of 8, is 8 less than 10 true? So whenever it is still true, we continue. Whenever we have to stop because this became false. The body of a while loop may not be executed at all. Why? Let me give you an example. Here is the meaning. I said while I is less than n. What is I? I is 1. If I give n that does not allow I to be less than it, we will never start. So if I give n as 1, if I say n is 1, we will never enter the loop at all. Why? Because 1 is not less than 1. Because 1, which is n, we cannot say I, which is 1, is less than n, which is 1. And that is where the code will stop. So that's why we say sometimes we don't even need to enter into this part. Oh, I made the mistake. I put my return 0 inside of. Now, okay, it's not actually inside of it. This is the closing brace for the while loop. Yeah, this is the closing brace for the while loop. A while statement can often be written in a variety of ways. A more concise version of our counter is this. We put the decrement operator inside of the print statement. I mean, this is a simple approach. Instead of writing I and then the next line you decrease I, you could actually write I minus minus here because we know that it won't change the value of I now, it will change it later after using it on this line. So anything it prints now is the same thing as I. no matter the plus minus minus that follows it, it will still be the value of I. So this is a way. Here we say we are making use of the side effect. The side effect helps us to decrement I, while at the same time it helps us to display I. Infinite loops. A while statement won't terminate if the controlling expression has a non-zero value. And so if you have a while loop, that the controlling expression would never become zero, then the while loop also would never stop. So here we say I is less than n. So it means something must change I to not be less than n, or something must change n so that it is not greater than I. Something must change in this controlling expression. So instead of multiplying, if you just say I is equal to if you just say I is equal to 2, if we happen to give n to be larger than I, this code will never stop anymore. Let's test. Let's test. So now it's asking for n. Observe that I is not a changing value. I is fixed as 2. So if we provide anything that allows this while loop to start, like if we provide any value that is greater than 2, if we provide n to be 3, we will enter into this loop and get locked in it forever. See, it's printing a lot of 2s, a lot of 2. So this is what we call an infinite loop, a loop that does not stop. So this is called an infinite loop. C programmers sometimes deliberately create an infinite loop, or sometimes they create it by mistake. Usually it is by mistake, sometimes deliberately, but most times by mistake, using a non-zero constant as the controlling expression. So this is a regular way. If you just write 1 inside of the expression, 1 is not 0, and we know that the while statement will terminate only when the test expression evaluates to 0. Since 1 is a constant, it never changes. It will always remain true. So we will have an infinite loop. Here is the implication. We can say while 1, and the loop will run forever. It will run forever because 1 is fixed. A while statement of this form will execute forever, unless its body contains a statement that transfers control out of the loop. So if its body contains some kind of statement that probably based on a condition, it helps us to break. Okay, that's nice. We can break out of that infinite loop. Or calls another function that causes the program to terminate. So here is a code called the square program. It prints a table of squares. So it asks you to enter a number of entries in each table. So if you in the table, if you want 5 rows, 1, 2, 3, 4, 5. So you provide 5. It sets the value of I and n. It tells us what it does, asks us the number of rows we want. We give it and it accepts it as n. It starts from while I is equal to 1. It checks if I is less than or equal to 5. So it has to print 1, 2, 3, 4, 5. It cannot exceed 5. Then it says percentage 10 in a field of 10. You remember this. This is M. In a field of 10. So in a field of 10, write the value of I. That is, I is what? 1. Then in another field of 10, write 1 times 1, 1. What happens next? Increase I by 1. Is I still less than 5? That is now 2. Is 2 less than 5? Yes, 2 is less than 5. So move to the next line and start to print again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The space of 10. Now write I, which is 2. And then write I times I, 2 times 2, which is 4. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Write 4. You increase I again by 1, that is 3. Is 3 less than 5? Yes. So again, do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do you write there? 3. Now, what is 3 times 3? It's 9. Put a space of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 times 3 is 9. Observe the relationship between this side and this side. It is the multiple of what is on the left. So this guy is 1 times 1. The next is 2 times 2. The next is 3 times 3. And this is what we call the table of squares. Here is another one. Sum.c program sums a series of integers that are entered by the user. So it accepts integers, adds them together, and then after adding them together, it displays the sum. Sums a series of numbers. Okay, let's look at the code. We define n, and at the same time, we define sum and initialize it to 0. Please, you need to learn these basic tricks in programming, that if you want something that you will do addition on from the base, it should be 0. If you need something that you would do multiplication on from the base, it will be 1. So now we are keeping sum and we are initializing sum to be 0. This program sums a series of integers, enter integers 0 and press 0 to terminate. Okay, we say while the number is not 0, then don't terminate. But if it is 0, terminate. This is just the meaning. Since we are saying that 0 should be used to terminate. If it is not 0, then you enter into the body of the loop. So what is n? We get n from the keyboard. After getting n from the keyboard, we check, is it 0? If it is 0, we stop. If it is not 0, then we add n to sum. So the value of sum becomes the value of n. And then we accept the next n. So this way it keeps accepting a value for n and checking that n is not equal to 0. Whenever n is 0, it stops working and then it prints the value of sum. It prints the value of sum. Okay, let's probably write the code for this and then we go for break. Okay, so here's our code. Let's look at the code if there are no errors. Here we get set variables and initialize one. We print our statement here. Okay, let's move to the new line here. We accept the value and then we check. If n is not equal to 0, then we do a few things. We increase sum by n and then we get the new value. We keep checking if the new value is not 0, we keep summing. Whenever the new value is 0, then we stop summing and we print the value of sum. Okay, I think this makes sense. Okay, so this is 5. It's asking for as many integers I can give, as long as they are not 0. So when I give 0, it stops accepting and it shows the result. Sum is 75. Okay, so what is going on? As simple as what we explained earlier. Here we set variables. Here we just pass a message. Okay, we need integers from you except 0. Whenever you want to stop the code, enter 0. And we begin to accept the values in line 7. In line 8, we are checking the value. Oh, it is not 0. Because if it is 0, it means we should stop accepting. We should print the result. But if it is not 0, then let's do something interesting. Let's add that value to a variable called sum. And then we get the next value. Okay, probably we can write something connotative here. So here we write 0. Okay, our code would look more connotative now. So here it is running line 6. It's saying enter integers. Enter 0 to terminate. So whatever you put here is going to end in line 7. Now it says enter the next integer or 0 to terminate. So this is line 10. As at this time, it has already added 5 to sum. So if we enter 0 now, the answer will be 5. Okay, so let's move ahead. Let's make it 10. Enter another integer 2, another integer 3, another integer 7, 1, 5, whatever, enter anything you like. It keeps reminding you that there's a way to stop the code. And whenever you want to stop the code, just enter 0. So whenever we enter -1, what happens? Nothing. -1 is not 0. So it only has -1. We stop it by entering 0. So it shows the answer. Is there any question? Anybody with a question? I'm waiting. Any question? Okay. If you do not have a question, we have 10 minutes break and we'll meet after 10 minutes. See you by 12 o'clock. Yes. So we will finish the last hour of our class now. We have discussed this code. We set two variables, sum and n. Sum is declared and initialized. N is only declared. There is no initialization. In the first printf, it's just a message. You don't really care much about that. The second printf also is a message, but it tells us something important, that 0 is not a valid input. 0 is an input to stop the code. And so in the next line, we begin to accept the values provided. So here we accept the first value. We check if the value is not 0. If it is not 0, we add it to sum. And then we accept the value again. We check again if it is not 0. If it is not 0, we add it to sum. And I remember in the implementation of the code, I tested even -1 for you. -1 means not 0. So it accepted -1 as part of the input integers. Later, when I entered 0, it made this expression to become true, and to become false, which means we stop and then we print this final part. All right. So this is the general form of the next iterative statement, the do statement. Let me change the color of my marker. Change to blue, the do. Observe. The last one is while. The last one is while. So we have discussed two now out of, we said we have three. We said we have the while, the do, and the for loop. Generally, we call this the do while, not just do, because after we have the do, we have a block of code which is ended with a while. Okay, so we go back to the do. So this is the general structure of do. We have the do, we have some statement, and then we have the while and the test expression. So observe that we will do this statement before we even get to the while. Look at the order of the statements. We have the do keyword, the statement, the while, and then the expression. So it means we will get to the do and the statement before we even get to the while. And this is why we say it will do it at least one time before testing the while. So when the do statement is executed, the loop body is executed first. What is the loop body? This statement. Then the controlling expression is evaluated. Then the controlling expression is evaluated. If the value of the expression is non-zero, the loop body is executed again. I mean, if we test this expression and it is non-zero, zero, remember zero is false in C. 0 is false for this kind of structures. So if the value is 0, it means stop. But if it is any other thing except 0, then it is non-zero. So we execute this body again and we come back to test. So we execute as many times until it becomes false. So here is an example. I is equal to 10. Do while. Then we have a block. T minus I and counting. So we are starting from 10. T minus 10 and counting. We subtract 1 and then we check. I hope it is still greater than 0. Let's look at that. Okay, so we got n. So we can say enter an integer. Enter maximum time. I think this is better. So we accept time into n. So here we can have our do while loop. Do while n is greater than 0. So what do we want to happen while n is greater than 0? We put that here. Right. Yeah. Okay, we can go to the next line and do minus, but it does not matter. We can do it here. We can just say an n minus minus. So it would write t minus any value we provide here as n, and subtract 1 in every iteration. So it says, okay, please give us maximum time. Let's say our maximum time is 10. Okay, it shouldn't be on the new line. Let's remove the new line character. Let's just do this way. Okay, so enter maximum time. Let's say 15. So it begins to count. T minus 15 and counting, minus 14, minus 13, 12, 11, till it gets to 1. Okay, let's just print something. Let's print something else here. So here we want to start with 8, and so it gets to time is up. So what did we do? We are evaluating this using the do while loop. Observe that n should be greater than 0. Let's violate this policy now, and you would see it would print at least one time. So if we say n is 0, it will still print 1, t minus 0 and counting, before it exits the do loop. Why? Because it does it first before it checks the while. When it checks the while, if it is false, it will not go back again. But at least it will do it. At least it will do it. So the do statement is often indistinguishable from the while statement. The only difference is that the body of a do statement will always be executed at least once. This part is very important. At least one time it will be executed. Even if the while expression will be false, it will still be executed once. It's a good idea to use braces in all do statements, whether or not they are needed, because a do statement without braces can easily be mistaken for a while statement. So here is the meaning. It's always good to put curly braces for a do statement. Why is it behaving this way? Okay, so look at what is going on. Without these braces, this is do this part, and this while looks like the beginning of a new while statement that does not have a statement because of the semicolon at the back of the while. So it's important for you to always put these curly braces so as to demonstrate that the while is for this do. A careless reader might think that the word while is the beginning of a while statement. So it's always good to put curly braces for do statement. Finally, the for statement. Finally, the for statement. Um, just a minute. Finally, the for statement. The for statement is the third iterative structure. It allows us, as like others, to go through a set of statements multiple times. But there's an important thing to know that the for is for definite iterations most times. The for statement is ideal for loops that have a counting variable, but it is versatile enough to be used for other kinds of loops as well. So this is the general form of our for statement. We have the for, expression 1, expression 2, and expression 3. Generally, we say expression 1 is the start condition, start. So we know the starting point of a specific variable, that is expression 1. Expression 2 is called the stop condition. Expression 2 is called the stop condition, while expression 3 is called the step condition. Step. So we have three things in the for loop: the start, the stop, and the step. So what is the start? I is equal to 10. This is the starting value of I. When will it stop? Whenever I is no longer greater than 0. That is when it will stop. This is the stop condition. What is the step? Every time we remove 1 from I minus minus. So that is the step. So if I is 10 now, the starting condition of I will be 10. The step of I will be minus 1. So the next value of I will be 9. The next one will be 8. The next one will be 7. And then it stops at 1. When it gets to 0, we don't continue. This is the for loop. Okay, but by the way, observe that I is used here, but it is not declared here. Observe what we have is just I. So before this line, you must have defined I. You must have declared I. You must have said int I. This is important. You must have declared I. I'm sorry about these lines that are popping up on the screen. I do not understand why I'm having these lines. Okay, let's quickly demonstrate this. Let's demonstrate the for loop. The for loop is probably the most interesting of our loops. For I is equal to 10, I is greater than 0, I minus minus. So as usual, it's good practice to always write the body of your for loop inside of a brace. So we don't need n anymore. Let's change to high. So we can say yes. So this is t minus percentage d and counting. What is percentage d? The current value of I. What is the current value of I? 10. Later, I becomes 9 because we will subtract 1. Later, I becomes 8 until I gets to 0. When it gets to 0, we stop the for loop and we jump to line 9. All right, let's see. It is t minus 10 and counting, t minus 9 and counting till we get to the end. The for statement is closely related to the while statement, except in a few rare cases. A for loop can always be replaced by an equivalent while loop, except in a few cases. So here is the equivalence. For a while loop, we have to first define our variable. We have to first say int x is equal to 10, and this is it. When would it stop? When x is equal to 0. So we say x should be greater than 0. So here is where we have it. Probably I should just write I is equal to 10. This is the same thing we have in the for loop. Here we say, I'm wondering why I'm having these lines all over. Okay, I'm not having lines with this. Why am I having lines when I'm trying to write things? So it has changed its mind. So here we have I is equal to 10. And here we say I must be greater than 0. Okay, we have to erase this again. I must be greater than 0. And then for the statement 3 is the step. So here we have I minus minus. If you observe, it looks like a for loop that was just rearranged. Expression 1 is the initialization step, which is what I called the start. That is performed only once before the loop begins to execute. After performing expression 1, we just go into the while statement for evaluation. Expression 2 controls the loop termination. This is what I call the stop. And expression 3 is an operation to be performed at the end of each loop iteration. And this is what I call the step. The result when this pattern is applied to the previous for loop is this. We have exactly the for loop structured as a while loop. Studying the equivalent while statement can help clarify the fine points of a for statement. For example, what if I minus minus is replaced by minus minus I? So if we have minus minus I here, what would happen? It would have no effect. Why? Because this line, though it looks above this line, it is not treated as if it is above the line. It is treated as if it is after this part. Is treated as if it is after it here. And that is why changing from I minus minus to minus minus I, which normally is different. Minus minus I is pre-decrement. I minus minus is post-decrement. So swapping them would not make a difference, because if you rearrange it in a while approach, you will see that it's different. Minus minus I is coming after we print the value of I. So it means the value of I at every time will always remain the value with which we enter into the for loop. This is the important thing, just as it is the way we enter into the while loop. So even if we have minus minus I, it will still print t minus 10, not 9. To still print t minus 10. Since the first and third expression in a for statement are executed as statements, their values are irrelevant. They are useful only for their side effect. Consequently, these two expressions are usually assignment or increment/decrement expressions. So what it means is this: these two do not affect the expression. I mean, do not affect the variable. Minus minus I does not change the value of I outside of this for loop to become, let's say, 1 or 0, because we only use them for side effect inside of the loop counter. The for statement is usually the best choice for loops that count up or count down. Why? Because it already has a nice structure for counting up and counting down. So this counts from starting point to when it is less than n. This counts from 1 till when it also includes n, but not beyond n. This subtracts from n minus 1 till it is low and it gets to 0. This counts from n till 1. Okay. Any question? Is there any question? Okay. So we'll stop here. I want you to write present in the chat if you're still there. I'll wait for a few seconds and I'll stop the meeting. Write present in the chat. Okay, I'm stopping the recording in 1 minute and I'm stopping the meeting in 1 minute. So I need everybody who is still present to write present or write here just like Onu wrote. Yes or no, you mark the attendance, you can leave.